Welcome to this explainer. Okay, so today we're diving into a massive shift happening right now in the AI space as of July 2026. For years, the AI race has basically been a brute force sprint to just build bigger and bigger models. But if you look at the latest developments, the ground is completely shifting beneath our feet. We're actually moving away from just chasing massive scale and figuring out how to build the ultimate AI factory. Let's take a look at mini CPM5, Forge Train, and the EP production layer. 1 billion. That is the parameter count for a new base model called Mini CPM 5-1B. Now, to put that into perspective, some of the giant frontier models out there are rumored to have well over a trillion parameters. So in that world, 1 billion seems almost remarkably tiny. But don't let that fool you. This seemingly small number is actually a Trojan horse. It's signaling the end of the manual scaling era and the beginning of something much, much more profound. Okay, let's dive into this. Through a process called quantization, this highly capable model is shrunk down to just about half a gigabyte. Half a gigabyte. That means this model isn't locked away in some massive energy-hungry cloud server somewhere. It runs everywhere. We're talking phones, car systems, web browsers, and entirely offline environments. It's literally putting heavy-hitting coding, math, and logic capabilities directly into our pockets and our everyday devices. But, here is the real secret. The lightweight model itself, it's just the visible tip of the iceberg. The deeper, far more significant achievement is the hidden production architecture underneath it all. What we're really looking at is the emergence of a self-accelerating AI-assisted production loop. The AI didn't just learn from data, it actually helped build the very factory that produced it. It is absolutely fascinating when you compare the old way of doing things with this new reality. The old paradigm was all about absorbing massive amounts of data with increasingly larger models, which required unbelievable amounts of compute and, honestly, agonizing manual engineering. But the new race? It's entirely about who can build the fastest, most reliable production architecture to actually produce capability. This whole system operates on a continuous 6-step production flywheel. We go from the model, straight into the Forge Train framework, then ultra data governance, hardware adaptation, evaluation, and finally edge deployment. Notice how the model isn't the whole show anymore. It's really just one converter inside a larger continuous loop where the next generation of models actually improves the loop itself. Now, what's really interesting about this is the definition of Forge Train. It is an AI-generated training framework. Just think about that for a second. AI agents are actively writing, testing, debugging, and optimizing the training infrastructure. They're shrinking a process that used to take human engineers months down to mere days. AI is no longer just the final product being trained. It has literally become part of the machinery that trains the next AI. But wait, having an AI write its own low-level kernel code? That sounds incredibly dangerous, right? And it is. That brings us to the energetic paradigm, or EP. Without EP control, you get an unstable loop, brittle code, and hidden regressions. Essentially, an AI just spinning out of control. EP steps in as the essential golden layer of control. It acts as the steering wheel and the brakes, giving us controlled boundaries, auditable production, and hard human approval checkpoints. And EP doesn't just stop at control, it demands proof. When a company claims high capability density, EP doesn't just swallow the marketing slogan. Instead, it uses a rigorous deductive process. It demands to know exactly what improved, why it improved, and what trade-offs were made to get there. It maps out the causal mechanisms to separate real usable gains from superficial benchmark illusions. To pull this off, EP enforces what we call constraint discipline across several layers: speed, correctness, portability, maintainability, auditability, and stability. Think of it like tuning a high-performance engine. Improving one part can easily blow out another. EP manages these trade-offs as a unified system. It makes sure that optimizing just for speed doesn't completely destroy the system's portability across different hardware chips, or, make it impossible for human engineers to actually maintain. Which leads us to an incredibly hard-hitting rule. Speed without traceability is fragile. While AI-generated automation is fantastic for moving fast, doing it blindly is a recipe for disaster. If your automated systems don't have failure memory, if you can't trace exactly why something broke, you're really just going to reproduce hidden defects at a massive automated scale. Let's apply this to the hardware side. Raw chip capacity is honestly useless without the right software layers to unlock it, things like compilers, memory layouts, and scheduling. This is what we call trapped capacity. Forge Train accelerates unlocking this from months to days, rapidly adapting the software to the hardware. But EP is right there with it, auditing the process to ensure numerical stability and making sure humans can actually maintain it in the long run. So, the crucial point is, this all relies on data. But under the Ultra Data Governance System, data isn't just fuel. It acts as selection pressure. It's almost like an AI's diet. Clean data improves reasoning efficiency, for sure. But if you over-filter, you remove rare, vital insights. Relying too much on synthetic data risks repeating older biases and technical blind spots, and benchmark tuning just creates misleading capabilities. Ultimately, the data pipeline decides what the model sees, what it values, and what it imitates. There is a truly fascinating perspective shift here. Failures are not waste. They are boundary information. In the old AI race, companies hid their failed training runs as expensive embarrassments. But the EP system completely reframes this. It treats every single failure as a strategic asset and a vital test case for the future. Instead of just tossing out errors, EP builds a memory bank out of them. We're talking data failure, framework failure, hardware failure, evaluation failure, control failure, and recursion failure. It sounds totally counterintuitive, but preserving these specific failures as hard constraints is exactly what makes the production loop smarter and safer over time. Because of this, we really have to rethink evaluation. The old way of relying purely on public capability benchmarks, that's out. EP introduces a rigorous evaluation governance stack. It evaluates capability, yes, but also deployment viability, transferability, stability, the infrastructure itself, and governance. It ensures that getting a high score on a test actually translates to success when deployed in the real world. And speaking of the real world, this brings us back to where this actually runs, the edge. Cloud intelligence is centralized, sure, but it comes with high latency and privacy risks. Small models like Mini CPM-5 solve this by distributing intelligence directly to local devices. But that creates massive fragmentation, with thousands of different devices to manage, which is exactly why the EP control layer is required to govern updates and consistency safely across the board. And this brilliantly illustrates what true recursive improvement actually looks like. If AI is going to build better AI, it can't just be about moving faster. Recursion requires meticulous tracking. 1. What changed? 2. Why did it change? 3. What improved or failed? And 4. What new risks emerged? Without this level of scrutiny, an automated system will simply repeat its own errors at a terrifying speed. So, bringing all these pieces together creates the complete competitive unit. The advantage in AI no longer belongs solely to the team with the biggest data center. The advantage now goes to the system that can repeatedly convert limited resources into better models, better infrastructure, better data, faster hardware adaptation, reliable edge deployment, and strong, independent evaluation. Which brings us to the absolute defining reality of this shift. The next AI moat is not the largest model, but the controlled production architecture that builds and improves future intelligence. That is the new industrial era of AI we're stepping into. And the energetic paradigm provides the absolutely indispensable governance layer to make sure that factory operates smoothly. So, I want to leave you with one final question to think about. Is your strategy focused on building the best model or the best factory? It is time to fundamentally rethink how we view the future of AI competition. Thank you so much for joining me on this explainer. I really hope this helps you understand the massive shifts happening just under the surface of the industry. Catch you next time.